Hi guys, you're welcome to God Academy. In this lesson, I'll be taking you through the cross products. In our previous lesson, we went through the dot products and you saw how to determine the dot product. Alright, so we continue in this lesson, the cross products. Please do well to subscribe if this is the first time you have been on this channel. What do we mean by cross products? So this one is a vector quantity, not a scalar quantity as dot. The first thing to know about this is that a vector. The idea of cross products is that we want to find a certain vector which is perpendicular to these two vectors in play. If I have A cross B, two vectors like this, I want to find a third vector, maybe C, which is perpendicular to this. So let's see here. Let's say vector A is here, which is 90 degrees to vector B. The cross product is simply another vector which is perpendicular to both of them. As simple as that. That is the idea of cross products. So for the mathematical representation, assuming I have A given as A1, A2, A3, and I have B given as B1, B2, B3, then my cross product A cross B is simply given as you introduce your direction vectors. As I said, this gives a vector quantity I, J, K. In 3 by 3, A become another row. I'll have my row 1, A1, A2, A3, my row 2, B1, B2, B3. And that is all. You find the determinant of this 3 by 2 matrix and that becomes your cross product. As simple as that. So let's solve and find the cross product of a matrix. For example 1. If A is given as 1, 3, 4, and B given as 2, negative 7, negative 5, find A cross B. Find A cross B. As I said, A cross B is simply the determinant of a 3 by 3 matrix with our first row as the direction vectors I, J, K. Then A will become the second row. Then B will become the next row, 2, negative 7, negative 5, right? I find the determinant. I'll start. You have plus, minus, plus. Is that not it? So I, which is positive, then you cancel the row. So all this will go away. I'll have my 2 by 2 matrix here, which is going to give me 3 times negative 5 minus 4 times negative 7. I have minus J, plus minus plus, don't forget. Minus J, multiplying. Remember, J will also clear off everything here and everything. So I'll be left with what? 1, 2, 4, negative 5. So 1 times negative 5 for J, right? 1 times negative 5 minus 2 times 4. And finally plus K, which will also nullify everything. I'll have this 1 times negative 7, right, minus times 3. For my I, out. So 3 times negative 5 is negative 15 minus 28. So it's going to be negative 15 plus 28. That will give us 13I, right? Then I'll have minus 5 times 1. Negative 5 times 1 is negative 5 minus 8, negative 13, right? Minus 13J. Then for our K, I'll have negative 7 minus 6, negative 13A. As simple as. So this is A cross B. Is a vector quantity, okay? Represented in the IJK standard. That is all. In cross products, there is another corollary here which is going to be so useful. It can help us find the angle between two vectors as well as the dot product did. Since you are dealing with angles, right? That can also help us a lot. So let's see how that is done. So the corollary is that if an angle theta, right, is between two vectors A and B, therefore A cross B, the absolute of A cross B, right, should be equal to absolute of A, absolute of B, sine theta. This is not cos theta as we had for the dot products. Okay, as simple as that. So there are some few things you've got to know here, which says that if the if two vectors, right, the cross product of two vectors is said to be 0 only when the two vectors are parallel. Please take note. because right now, if this is 0, what does it mean? Sine 180, right? So you search, you punch sine 180. Sine 180 is 0, right? So if two vectors are parallel, they will be either, you can also find sine 0. Sine 0 is also 0 because either you say 180 or the angle between them is actually what? 0. As simple as that, right? So it's simply what? 0. Let's take note of it. Therefore, so two vectors are said to be perpendicular when their dot product is 0, and they are said to be parallel when their cross product is 0. Take note of this. It's also important. And also, we can use cross product to find or determine the area of a parallelogram. So area of a parallelogram is given as area of a parallelogram is given as simply the magnitude of the cross product of the two vectors. Please take note. This is another thing you should take note of. So to find the area of any parallelogram, simply find the magnitude of the cross product. And for us to find just the area of a triangle, which is half a parallelogram, right? And that will give us half absolute cross A cross. So this is simply half of the parallelogram. Take note of this one too, it's also important. Then generally we say that if two vectors are if the cross product of two vectors is said to be 0, then the two vectors are said to be collinear. Collinear, as I said, is 180, right? So vector A then vector B will have the same direction. They are said to be collinear or linearly dependent. Let's take an example here. So for an example, I have find a vector, right, perpendicular to the plane that passes through the points P 1, 4, 6, Q negative 2, 5, negative 1, then R 1, negative 1, 1. You have to find a vector perpendicular to the plane this. Remember that you can find cross product of two vectors, not 2 points. These are points. We have Cartesian points and you have vectors. These are not vectors, okay? They've given you just the points, or let's say the vertices of some points in space. And you've been asked to find a vector perpendicular to this plane, okay? So that is it. It's so simple, right? As I'm saying, we have P, Q, then R in spatial distribution. So let's say this one is connected to this is connected to this. We can create two vectors out of this. And what cross product says to do is that we need to find a vector that is perpendicular to any of these. I mean, it should be perpendicular to anything. So you realize that, let me do it well here. I have a plane here, right? I have P, Q, and R. For me to find a vector that is perpendicular to this plane, it should be what? 90 to everything in this plane, right? Therefore, if I find a vector PQ or a vector PR and I find a cross product, that gives me this vector I'm looking for. So let's find the vector PQ and the vector PR. We need a point of vectors, right? So we are going to look for vector PQ, then we look for vector PR. As simple as that, okay? So now what is vector PQ? To find a vector PQ is given as vector OQ minus vector what? OP. Is that not it? Given the vertices we have here, I'm going to have negative 2, 5, neg 1 minus my P, right? Which is 1, 4, and 6. So here we do simple arithmetic operation here. Negative 2 minus 1 is negative 3. 5 minus 4 is 1. Neg 1 minus 6 is negative 7. Therefore, I have my PQ. Let's find PR. To find my PR is OR minus OP, right? This gives us, what's our OR? 1 neg 1, 1, right? For here, 1 neg 1, 1 minus my OP, which is 146. So this gives me 1 minus 1, which is 0, negative 1 minus 4, negative 5, 1 minus 6, which is what? Negative 5. Therefore, I have PQ, I have PR. To find this vector perpendicular to the plane, it should be the cross product of PQ and what? PR. As simple as that. So let's find a cross product. To find a cross product is so simple, right? You introduce your direction vectors I, J, and K. Then you write your vector PQ as a row. I'll have -3, I'll have 1, -7. I'll have 0, -5, -5. Then we find the determinant. So I'll introduce my I, open bracket. It will nullify everything here. Then my 2 by 2. 1 neg5 minus neg5 minus neg5 times neg7. Take note of that. Then I'll have it's plus minus plus, don't forget. Then I'll have minus j. J will nullify here. I'll have -3 times -5. Right? Minus 0 times what? -7. Then I have plus k. K2 will nullify everything. I'll have this -3 times -5 times 0 times 1. So for my I, I'll have 1 times -5 is -5 minus, this will give me positive 35. Right? So -5 minus 35 minus 35 will be what? -40i. When I come here, I have 3 times 5 is positive 15 minus 0. So minus 15j. Then here too, 3 times 5 is positive 15 minus 0. That will be what? 15, positive 15k. As simple as that. So this vector is the vector which is actually what? Perpendicular to the plane carrying those vertices. And that is nicely how this is being solved. As simple as that, right? So we solve more examples in our future tutorial. So don't forget to join us for our future tutorial. Don't miss it. You can't afford to miss it. Subscribe and you share, and I'll see you.